So here's your guys' homework on graphing log functions. Alright, so we'll begin with number 1. Okay, so first you guys have to get your guys' critical value from the parent function. So fortunately, this one is a parent function. So we are going to have 1 comma 0 and b comma 1. So remember, your guys' b value is this value right here, and I'm going to highlight it in red. So that right there, you guys, is your b value. For our coordinates, it's going to be 1 comma 0 and 3 comma 1. So there's our 2 points, no transformations, so we just have that. So let's plot it. We got 1 comma 0 right here, and we have 3 comma 1 right here. Okay, so now let's get your guys' asymptote. So you guys just set this equal to 0, which means it's going to be x is equal to 0. So this is your guys' asymptote. So I'm going to put my asymptote right there. And I'm going to plot the asymptote. X is equal to 0 is on this y-axis line. Okay. Next, let's find our x-intercept. I'll do this in a different color. We'll do green. Oh, let's graph this. So your guys' graph looks like that. Now let's find your guys' x-intercept. So your guys' x-intercept, you set f of x equal to 0, and you guys solve. So 0 equals log base 3 of x. Now make it into exponential form. So 3 to the 0 power is equal to x. 1 is equal to x. So 1 comma 0 is our x-intercept. Okay. Domain and range. So how far left does this graph go? So let's do this in purple. Let's make that bigger. Alright, so domain, how far left is this graph going? Well, it's stopping right there, which is the value of 0. So 0. And how far right is this graph going? All the way to infinity. So 0 comma infinity. Range, how low does this graph go? Well, if you guys take a look, it goes all the way to the bottom. So negative infinity to how high this graph goes. Follow, 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 follow. And if you guys notice, it's slowly but surely just going to continue to just go upward. So it's going to be infinity. All right, and behavior. So take a look. You guys, when you see that, right, that means when x is going towards infinity, which means it's going up. So when this graph is going up, it's over here, right? And that's when x is approaching infinity. Now, where is this graph approaching negative infinity? And that is down here, right? And notice, you guys, that's when x is approaching 0 from the right-hand side. We also did this one in our notes, you guys, so there's that. Number 2. All right, starting from the top. Okay, so for the parent function, it's always 1 comma 0 and b comma 1. So we're going to disregard that for now. So remember, your guys' b value is this one. So we know from the parent function, it's just going to be 1 comma 0 and 1/2 comma 1. Now we are going to be integrating this transformation here. So remember, this, you guys, is going up 3. which means how is it affecting your guys' coordinates? Well, since it's going up 3, that means you add the y coordinates by plus 3. So our new coordinates are going to be 1 comma 3 and 1/2 comma 4. So let's plot that over here. 1 comma 3, you guys, is right here. 1/2 comma 4 is right here. All right. So now let's get your guys' asymptote first. So set this, you guys, equal to 0. So x is gonna, your guys' asymptote is x is equal to 0. So we're gonna plot that. And now we can finally graph. So here's your guys' graph of your function. Something like that. All right. X-intercept, you guys set f of x equal to 0. So let's get x-intercept, set f of x equal to 0. So we're going to have 0 is equal to log of 1/2 x plus 3. So let's solve for x. So subtract 3 from both sides. Negative 3 equals log 1/2 of x. All right, so to change this from log form to exponential form, it's going to be 1/2 raised to the negative 3 is equal to x. All right, you guys, so when you guys have a negative exponent, one strategy you guys can use is just take the reciprocal, and then you guys will have a positive power. So if we do take the reciprocal on the inside, it's 2 over 1. But 2 over 1 is just 2. So 2. Now it's to the positive 3 power is equal to x, and that's going to be 8 to the equals x. So that is 8 comma 0. That is going to be our intercept. So we had x was equal to 0 for the asymptote, and we have 8 comma 0 for the x-intercept. All right, domain, how far left this graph goes, negative infinity. How far right, positive infinity. Oh, sorry. How far left does this graph go? It goes to 0. How far right? Positive infinity. Range, always going to be negative infinity to infinity. All right, end behavior. So when f of x approaching infinity, it's over here, right? And that's when your x of value is approaching 0 from the right-hand side. Now, when f of x is approaching negative infinity, which is down here, x is approaching positive infinity. So that's your guys' end behavior. All right, number 3. So let's set this up again. So remember from your guys' parent function, it's always 1 comma 0 and b comma 1. We're going to disregard that for now because that's a transformation. So from this parent function, you guys, your guys' b value is the 4. So 1 comma 0 and 4 comma 1. So that's strictly from just the original function, you guys. Now we're going to add this. So remember, this goes left 5. And left 5, you guys, that affects that by subtracting 5 from your x values. So we're going to get negative 4 comma 0, and we're going to get negative 1 comma 1. So if we plot that, negative 4 comma 0, 1, 2, 3, 4, and negative 1 comma 1. There we go. Now it's time for the asymptote. So set this, you guys, that parenthesis equal to 0. And we're going to get x plus 5 equals 0, x is equal to negative 5. This is your guys' asymptote. So we're going to plot that. X is equal to negative 5, which is right here. Yep, and I'm going to say x is equal to -5. All right, x-intercept time, you set f of x equal to 0. So 0 equals log base 4 of x plus 5. Now make this into exponential form, so 4 to the 0 power is equal to x plus 5. 4 to the 0 is 1, which equals x plus 5, and subtract 5 from both sides, -4 is equal to x. So -4 comma 0 is our x-intercept. Oh, I forgot to graph this, so let's graph this right now. Okay. Domain, how far left does this graph go? All the way up to the asymptote, so -5 to infinity, how far right? And range is always -infinity for infinity for the domain. Or sorry, for the range of log functions. Okay, end behavior. So as f of x continuously goes upward, right? That means, well, this is where x is approaching infinity. So this is infinity. Now, where is f of x approaching negative infinity? It's down here. So in order for f of x to approach negative infinity, x has to approach the vertical asymptote. So -5 from the right-hand side. Okay, so there's that over here. All right, so again, start with your guys' critical values of 1, 0 and b, 1. Remember, this is your guys' b value right there. So it's going to be 1, 0 and 2, 1. And now we are going to use our transformations, okay? So from this, we know it's left 8, and from this, we know it's down 4. So this is going to affect our parent function by going left 8, which is -8 to the x coordinates, and down 4, which is -4 to the y coordinates. We're going to have -7, -4, and we're going to have -6, -3. Plot those. So -7, -4. We got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Right there. 1, 2, 3, 4, 5, 6. 1, 2, 3. Right there. Okay, asymptote time. This is your guys' asymptote, so set that equal to 0. X is equal to -8. This is your guys' asymptote. So we got this. Now get your guys' graph. So snug, 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 and now start turning. It's just a sketch, so there you guys go. Alright, x-intercept time. So for your guys' x-intercept, set f of x equal to 0. So we get 0 is equal to log base 2 of x plus 8 minus 4. Solve for x, so add 4 to both sides. 4 is equal to log base 2 of x plus 8. Change it to exponential form, so 2 to the 4th is equal to x plus 8. 16 is equal to x plus 8, minus 8, minus 8. 8 is equal to x. So your guys' x-intercept is going to be 8, 0. So we got x equals -8, and this one's going to be 8, 0. So technically, your guys' graph should more look like this. All right. Okay, so domain, how far left does your graph go? All the way until it hits the asymptote, which is -8. And then how far right? Infinity. How far down does this graph go? Negative infinity. How high? Positive infinity. All right, and behavior. So when it gets to when f of x is approaching infinity, it's really over here. And that's when x is approaching infinity. So infinity. Now for this one, as f of x approaches negative infinity, it's down here. So that's when x is approaching the asymptote -8 from the right hand side. Okay. Now we got this one. So let's get your critical values 1, 0 and b, 1. Remember your b value is this one value right there, so you guys are gonna have 1, 0 and 1/3, 1. Alright, so now we're gonna look at our transformations. So this one right here, you guys, is right 4, which means your guys' parent function's coordinates are gonna add 4 to the x coordinates only. So we're gonna have 5, 0. Now 4 plus 1/3, you guys. So 1/3 plus 4 over 1. To get the common denominator, times top and bottom by 3. And you guys get, well, it's all going to be under 3. And then 4 times 3 is 12. 12 plus 1, 13. 13 over 3, 1. So 1, 2, 3, 4, 5. There's 5, 0. 13 over 3, 1, you guys, is like 4.3. So 1, 2, 3, 4, 4.3, 1. So something like that. Okay, intercept time. Set this equal to 0. So x minus 4 is equal to 0. Add 4 to both sides. X is equal to 4. This is your guys' asymptote. And then to find your guys' x is equal to 4. Oh, forgot to plot that. Oh, that's 3. 1, 2, 3, 4. Okay, there's x is equal to 4. Graph that. So that's going to look like this. Alright, so now let's get your guys' x-intercept. Set f of x equal to 0. 0 is equal to log base of 1/3 x minus 4. So we're going to change this to exponential form. So 1/3 to the 0 power is equal to x minus 4. 1/3 to the 0 power, you guys, is 1. Anything to the 0 power is 1. Add 4 to both sides. 5 is equal to x. 5, 0. So 5, 0 is our x-intercept. Now let's do domain and range. So how far left this graph goes? All the way to the the vertical asymptote. So 4 to infinity. What is the range? How low does it go? Negative infinity. How high? Infinity. All right, and behavior. So here is where f of x is approaching infinity, and that is where x is approaching the vertical asymptote. So x is approaching 4 from the right hand side. So here, f is approaching negative infinity down here, and that's when as x approaches infinity, it's going to approach negative infinity. Okay. Number 6. Alright, number 6, you guys. So you guys have critical values. So 1, 0, b, 1. Your guys' b value is that right there. So you guys are going to have 1, 0, and 5, 1. Now let's look at our transformations, right? So this tells you right 2. This tells you down 1. So these transformations affect your original parent function coordinates by right 2. That means you add 2 to the x coordinates. Down 1 means you subtract 1 from your x. So 3, -1 and 7, 0. So we're going to plot 3, -1 is right there. 7, 0, 4, 5, 6, 7 is right there. And now let's get your guys' asymptote. So set this equal to 0. X minus 2 is equal to 0. Add 2 to both sides. X is equal to 2 for the asymptote. So 1, 2, 3, 4, 5, 6, 7, 8. There we go. And this is what your graph should look like. Okay. X-intercept time. So x-intercept is when you set f of x equal to 0. So 0 equals log base 5 of x minus 2 minus 1. Add 1 to both sides. 1 is equal to log base 5 of x minus 2. Change it to exponential form. So 5 to the first power is equal to x minus 2. Add 2 to both sides. 5 plus 2 is 7 is equal to x. 7, 0. So let's write this information down. Asymptote was at 2. X-intercept at 7, 0. Now domain. Domain is how far left does this go? It goes up to the asymptote, which is at 2, to positive infinity. Range is always negative infinity to infinity for log functions. All right, and behavior time. Where is f of x approaching infinity? Right there. And that's when your x is approaching infinity. So infinity. Okay, f of x approaching negative infinity down here. And this is when x is approaching the vertical asymptote from the right hand side. So x is approaching 2 from the right hand side. Okay, last one. All right, this critical value is 1, 0, b, 1. Your guys' b value is right there at 1/4. So 1, 0 and 1/4, 1. All right, your guys is now we gotta find your transformation. So this tells you guys right 1, and this tells you up 1. So right 1, you guys, that means you add 1 to the x coordinates. Up 1 means you add 1 to the y coordinates. So we're going to get 2, 1, and we're going to get, okay, so 1/4 plus 1/1. Now, common denominator 4, so you got to multiply top and bottom by 4. So that means you guys are going to get everything over 4. 1 times 4 is 4. 4 plus 1, 5. 5/4, 1. So we're going to get 2, 1 right there. So 5/4, you guys, that's a little bit above 1. So a little bit above 1, 1, which is, oh, whoopsies, that's supposed to be a 2. So 2, 1, and then 5/4, 2 is going to look something like that. All right, asymptote time. So we're going to get x minus 1 is equal to 0. Add 1 to both sides. X is going to equal to 1. This is your asymptote. So we are going to plot that. Okay. X-intercept. Set f of x equal to 0. So 0 equals log of 1/4 x minus 1 plus 1. subtract 1 from both sides. Negative 1 is equal to log of 1/4 x minus 1. Exponential, 1/4 to the negative 1 power is equal to x minus 1. So in order to get rid of that negative sign, you guys, just take the reciprocal on the inside. So 1/4 is going to be 4/1, which is simply just 4 to the first. Add 1 to both sides. 5 is equal to x. So we're going to get 5 comma 0. So we got x is equal to 1, and your x-intercept is 5 comma 0. I forgot to graph this, so your graph, you guys, looks like that. Okay, domain, how far left does this go? All the way up to that asymptote. So 1, how far right? Infinity. The range for logs is always negative infinity to infinity. Alright, so with the range, it approaches infinity up there, and that's when your guys' x value is approaching that asymptote. So 1 coming from the right hand side. F of x approaching negative infinity right here, and that's when your guys' x value is approaching infinity. So infinity. So this is some pretty good practice right here, you guys. So good luck, okay?